All right, guys, so we covered molarity, molality. There's a third measurement of concentration, and that's the mole fraction. Mole fraction, it's abbreviated with the symbol X, and a mole fraction to solve for it is very simple. You're just taking the one component in moles divided by the total moles of solution. So when I say component, what I'm talking about is the solute or the solvent. So typically mole fraction is X plus a subscript of which component you're actually measuring. So if you're trying to measure the mole fraction of the solute, then you would write it X solute. If it's solvent, then it'd be X solvent. To solve for what's the mole fraction of the solute, say sugar and water, how much of the moles of the sugar is per the total moles of the solution. You would just take the moles of that solute and divide it by the total moles of the solution, and then vice versa. You would take the moles of the solvent, say water, and then you would divide it by the total moles of the solution to find the X component of that solvent. Let me break this down for you in a practice problem, and it will clarify any confusion of like what this means. All right, guys, here's a practice problem. What is the mole fraction of sulfur dioxide, which is SO2, in an industrial exhaust containing 120 grams of SO2 dissolved in every 1500 grams of CO2? Now, if SO2 is the one being dissolved, then that means it's a solute, and the solvent would be the CO2. Sometimes it doesn't just straight up tell you this. You have to use some just critical thinking to figure that out. But most of the time it doesn't even matter, because if you can find the X components of each one, then sometimes you don't really need to know every time which is a solute and which is a solvent. All right, so the first step here, you always convert to moles, because if you remember the mole fraction, to solve for the mole fraction, you have to take the moles of a solute or the moles of a solvent divided by the total moles of the solution. So first step is always convert to moles. So here we go. So we have 128 grams of SO2. Okay. So here we have moles SO2, and it gave us 128 grams of SO2. We need to convert that to moles. So after you find the molar mass of SO2, you add up 1 sulfur, 2 oxygens, you get 64.04 grams per mole. And then once you convert that out, multiply the top divided by the bottom, you'll get 1.99 moles of SO2. So boom, converted to moles. Now you have to do it for both though, because remember it's divided by total moles of the solution. So everything needs to be in moles. So you also convert CO2 to moles. It gives you 1500 grams of CO2, and we know 1 carbon and 2 oxygens. You add that up, it gets 43.99 molar mass per mole. Multiply the top divided by the bottom, you should get 34.09 moles of CO2. That's your first step. Convert to moles, everything. Second step is now it's asked, the question is, what is the mole fraction of sulfur dioxide? So mole fraction, remember, abbreviated X. We're looking for SO2. So you can write it X subscript SO2. I know that's small to see, but it's X subscript SO2. That's what we're looking for. So that'll go up on the top, and then you divide it by the total moles. And if you were looking for X component of CO2, then it would be X CO2, put that on top, divided by the total. So vice versa. It's not hard. It just takes a little bit of practice, and we'll have some more practice problems in a worksheet you'll do, and I can help you guide through that process. But so here, so to find the exponent of SO2, it's moles of SO2 divided by the total moles of the solution. So here we go. What's our moles of SO2? We have 1.99 moles SO2 divided by the total moles of the solution. So you just add them up. You have 1.99 plus 34.09 moles, total moles. This is total. That's the abbreviation for total. You'll need to learn it. So 1.99 divided by 1.99 plus 34.09. So there you go. You do your math, and it should come out to x. The x mole fraction of XO2 should be 0.055. There are no units for mole fraction because everything's mole and everything cancels itself out. So the two moles cancel each other out. So there are no units for mole fraction. So your answer should just be 0.055. Now, if you were to go and solve for CO2 right now, which you could for fun, you would just put 34.09 up top and divide it by the same thing, 1.99 divided by 34.09, which is the total. Then your answer, you'll get an answer. When you add up all the x components, it'll equal 1. And so know that. That's an easy way to check your answer. When you add up the components, it will add up to 1. If it doesn't, you did it wrong. So test it. That's mole fractions. I'll give you guys a few practice problems. Go ahead and go over that, and then next week we can cover anything you guys aren't understanding, and we'll move on from there. But one more week and we're done.